Hello everyone. The last time we met, we spoke about redox reaction. I also said very soon we'll be discussing how to balance redox reaction. So the first method I'm discussing right now is balancing redox reaction by half cell equation method. So let's balance the following equations using half cell equation method. The first one is sodium solid and hydrogen ion to give sodium ion and hydrogen gas. So anytime you see whether plus or negative, so just know that that is an aqueous solution, that is AQ. So how do we balance this? The first thing to do is to identify the one that is actually undergoing oxidation and the one that is also undergoing reduction. So let's check if sodium is undergoing reduction or oxidation. We said a time ago that oxidation is actually what? The increase in oxidation number. So let's check if oxidation number of sodium increased or not. In its free state, sodium is 0. The oxidation number of any element in its free state is always equal to 0. So let's place 0 here for sodium. Sodium is plus 1 here. Do not forget the oxidation number of an ion is the charge on it. So the charge on this one is plus 1. So it's moved from 0 to plus 1. That means there's an increase in oxidation number. Let's write it ionically. Na going to Na plus. So from here, which part do we place an electron? You know, I told you a time ago that we don't write negative in redox reaction. We prefer to write positive. So we'll place the electron here. That's one electron is actually what being removed from sodium atom to become sodium ion. So instead of me writing minus electron here, I'd rather take this minus electron to this other side to make it what? Positive. Hydrogen is moving from plus 1 to 0. Then I will write the ionic equation. Do not forget, hydrogen is diatomic. So because of these two, there will be an effect in the coefficient of the ion or this hydrogen and also the electron. So if it's 2 electrons, if it's 1 electron, that I will have to multiply by 2, and this we have to multiply by 2 because of this subscript of hydrogen, because it's hydrogen gas. So let me write this equal. This is aqueous, and this is also aqueous. How many electrons? Plus 2 electrons. Then I'll place 2 here to make equation balanced. Then I'll place gas here. This is undergoing reduction. I want to check if the equation is balanced. To balance the equation, I will have to consider the electrons. The coefficient of electrons must be equal in both cases. So this one is 1 here, this one is 2 here. I will have to combine the two equations. Before I combine the two equations, I multiply the first equation by 2 because of this coefficient of electron, and this one will be multiplied by 1 because of the coefficient of electron. So let me do the same. Let me do that. I placed 2 here times 2. I multiply this by 1. So in writing the equation, this is 2 Na solid to give 2 Na2 plus aqueous plus 2 electrons. This is still oxidation half cell equation of X, and this other one I'll multiply everything by 1, so which will still give me 2H plus aqueous to give plus 2 electrons to give hydrogen gas. This is undergoing reduction. Then the next is to combine the two equations to be 2Na solid plus 2 hydrogen gas aqueous plus 2 electrons, then 2 sodium aqueous plus 2 hydrogen gas, then 2 electrons. And after that, the electrons must cancel out. This cancels this. Then the overall equation then becomes 2Na solid plus 2 hydrogen gas to give 2 sodium ion aqueous, 2. Then the overall equation becomes 2 sodium solid and 2 hydrogen ion, then 2 sodium ion and hydrogen gas. So this is the net equation, and say the equation is balanced. Let's work on this other one, which is ion 2 ion aqueous, then chlorine gas to give ion 3 aqueous and bromide ion. So how do we work this? The first thing to do is to identify the one that is actually undergoing oxidation and the one undergoing reduction. So let's check if ion 2 is undergoing oxidation or reduction. Do not forget, the oxidation number of an ion is the charge on it. So the charge on this ion 2 is +2. The charge of this ion 3 is +3. So let's check if there is increase in oxidation or decrease in oxidation. So it moved from +2 to +3, therefore it's undergoing oxidation because there's an increase in oxidation number. So let's write it: ion 2 to ion 3. Now place the electrons here. So we say this is undergoing oxidation. The other one is definitely undergoing reduction, but let's check. We move from 0 here because this is the free state 0, and so sorry, my bad. I actually wanted to write chlorine, but I wrote bromine instead. I'm changing it right now. So this Cl minus. So then this Cl moved from 0 to -1. So is that reduction or oxidation? Is definitely reduction because there is a decrease in oxidation number. So Cl2, which is gas, going to Cl minus, which is aqueous. So from here, 2 electrons will be added to this, then 2 will also be added to this to make the equation balanced. Then after that, you can actually confirm it to know if everything is actually working perfectly. We say we need to check the charges. So what's the charge on this? The charge on this is 0. The charge on this one is 0. The charge on this is -2. And the charge on this is 2 times -1 will give you -2. So this is -2 to -2. So we say the charge is what? Balanced. So that's why we are writing +2 here. So in case you don't know it before, just know that is exactly what we do to know where to place the plus electron or not. Okay, moving on. What we had earlier was ion 3 and ion 2. We want to check if the electrons are the same. The electrons are not the same, but because here this +2 and here this is just 1. So what do? We need to make this, we need to multiply this one by 2 and multiply the denominator by 1. So this is, and we need to multiply this by 1, this reduction. When you're multiplying all this by 2, that becomes 2Fe2 plus to give 2Fe3 plus 2 electrons. Then the next is Cl2. This is gas. This is aqueous. This is aqueous. Then the next is 2 electrons to give 2 Cl aqueous. Now that the electrons are the same, you can even cancel the electrons from here. So, but I prefer just to make everything combined this way. Combining everything, this becomes 2Fe 2 plus Cl Cl2 plus 2 electrons to give 2Fe 3 plus 2 electrons plus 2 aqueous. Then electrons will cancel out. This cancels this. Then you'll be left with 2Fe 2 plus Cl2 gas to give 2Fe 3 plus 2 Cl negative. This is aqueous. This is aqueous. So the equation is balanced. The next is to balance redox reaction in acidic medium. This is manganate, that's tetrazomanganate 7 ion, and ion, that's tin and tin 2, both aqueous, is also aqueous, to give manganese 2 ion and tin 4 ion, both aqueous. So the first thing is to identify the one that is undergoing oxidation and the one that is undergoing reduction. So let's check if tetrazomanganate 7 is undergoing oxidation or not. Don't forget, in our previous class I taught you how to calculate the oxidation number. So let's calculate the oxidation number of this tetrazomanganate 7. The oxidation number of any ion is the charge on it. So this charge is -1. So for us to get the manganate, Mn plus -2 times 4 is equal to -1. So Mn still plus -8 is equal to -1. This Mn -8 is equal to -1. Mn is equal to -1 plus 8. Mn is equal to plus 7. So the oxidation number of manganese here is actually plus 7. So let's check that of tin. So this is already 2 because it's charge on it, plus 2. This is plus 2 and this is plus 4. So that means it shows that manganese is going from tetrazomanganate 7 to manganese 2. So is that reduction or oxidation? It's definitely reduction because there's a decrease in oxidation number. So let's write it. MnO4 minus, which is aqueous, so Mn2 plus, which is also aqueous. So what do? This move from plus 7 to plus 2. It is definitely undergoing reduction. But in this case, this is different from the first one we did. How do we work this? It's very simple. All you have to do is, where there is deficiency of oxygen, you need to place water there. And where there is sufficient oxygen, you need to place hydrogen ion there. So let's go. Here there is enough oxygen, we need to place hydrogen ion there. Mind you, how many electrons do we need to add to this? That's 5 electrons, because move from plus 7 to plus 2, that means 5 electrons need to be added to this. 5 electrons. Here you need to add water to this and add hydrogen ion to this. So the first thing you have to consider here is to balance the atoms. So in balancing the atoms, this is manganese, it's one here, manganese also is one here, oxygen is +4 here, oxygen is just 1 here. So what do? Let's place 4 in this place. So oxygen is 4, hydrogen is 1, hydrogen is 8 here. We need to place 8 electrons here. So after balancing the atoms, we need to balance the charges. So in balancing the charges, this is -1, -1, this is +8, this is -5, -5. Would that give us +2? Because manganese is +2 here, +2. So let's check if everything is balanced. This is -1 + 8, that is 7. Then 7 - 5 is +2. So we have +2 here, going to +2 here. That shows that the equation is balanced. The next thing to do is to look at the other equation, half cell equation. So this is definitely undergoing reduction. So this is RED, that's reduction. The second one is definitely oxidation. So I'll write it SN2+ going to SN4+. This is aqueous, this is also aqueous. How many electrons we moved? 2 electrons, 2 electrons. The reason I will not be adding water molecule and hydrogen ion to any one of them is because there is no oxygen in any of these, so I don't have to do that. It's only when I have oxygen and deficiency of oxygen in any one of them, I will add water and also hydrogen ion. So what do I do after this? The equation is actually balanced because this +2 here, this is 4, then you have -2, 4 - 2 is 2. So the equation is balanced. And if you want to check charges also, this is +2 moving to +4 - 2, that is +2, then +2. The charges are balanced. So next is to combine the two equations. So combine the two half cell equations. This is definitely undergoing oxidation, OX. So the first one, which is reduction, that's manganese ion +8 hydrogen ion +5 electrons to give manganese 2 +4 water molecule. This is aqueous, this is aqueous, this is aqueous, and this is ion on its own, liquid rather, which is reduction. The next one is SN2+ to SN4+ +2 electrons. You get to know that number of electrons here are 5 and number of electrons here it's actually 2. So I'll multiply this one by 2, then I'll multiply this by 5. When I multiply this by 2, this becomes 2Mn O4- plus 16 hydrogen ion plus 10 electrons to give 2 manganese 2 ion and 8 water molecule. This liquid, this is aqueous, this is aqueous, this This is also aqueous. The next, I will apply all these by 5 as 5 SN 2 plus to give 5 SN 4 plus 10 electrons. This is aqueous. This is aqueous 2. So the next is to add the two equations. That will be 2MnO4 minus aqueous plus 16 hydrogen ion aqueous plus 10 electrons plus 5 SN 2 plus, which is aqueous still, to give 2Mn 2 plus, which is aqueous, plus 8 water molecule, which is liquid, plus, mind me, I'll write it here, plus 5 SN 4 plus 10 electrons. So you get to know that the electrons will cancel out. This cancels this. Then after that, I have the overall equation, which is 2MnO4 minus aqueous plus 16 hydrogen ion aqueous plus 5 SN 2 plus aqueous to give 2Mn 2 plus aqueous plus 8 water molecule plus liquid plus 5 SN 4 plus. So this is the net equation. The last one, which we'll be discussing, is to balance in basic or alkaline medium. In balancing redox reaction and alkaline medium is actually very simple, but how do we go about that? The rules are actually very similar to that of acidic medium, but should be very careful. Let's balance example in basic medium. So let's look at chlorate ion reacting with sulfur for oxide to give chloride ion and sulfite. This is aqueous, this is a gas, this is aqueous, this is gas. The first thing we have to do is to identify the one that is undergoing reduction and the one that is also undergoing oxidation. So this is chlorate, trioxochlorate 5, that's what we call it, but let's check it. The oxidation number of chlorine in chlorate, this is Cl. Do not forget this -2 plus -2 times 3 is equal to -1. So from here, this Cl plus -6 is equal to -1. This Cl is equal to -1 plus 6, and Cl is equal to plus 5. That shows that the oxidation number of chlorine in this chlorate is plus 5. So it's moved from plus 5 to -1. SO2. The oxidation number of a compound is of a neutral compound is always equal to 0. So we are looking for the oxidation number of sulfur here. This is S. Oxidation of oxygen in any compound is -2 except peroxide with -1. So this is -2 times 2 is equal to 0. S -4 is equal to 0. S is equal to plus 4. So it's moved from plus 4 to what? Let's check that of this. This is S plus negative 2 times 3, which is equal to 0. S plus negative 6 is equal to 0. S negative 6 is equal to 0. S is equal to plus 6. So it's actually moved from plus 4 to plus 6. Plus 4 to plus 6. That means there's an increase in oxidation number. So this one is undergoing reduction, while this one is undergoing oxidation. So let's write the two half-cell equations. It's ClO3 minus to Cl negative. How many electrons? Since this one is undergoing reduction, how many electrons do we need to write? That's 6 electrons, because we from plus 5 to negative 1. So how do we do that? Remember your number line in mathematics. There's negative 1 here, 0, 1, 2, 3, 4, and this is 5. So we need to move backwards. How many times do we need to move backwards? From 5 to 0 to negative 1. So that's 1, 2, 3, 4, 5, 6. So that's 6. Shows that we need to add 6 electrons to it. So where we are adding these 6 electrons, we will definitely be adding it somewhere here, plus 6 electrons to give you this. So in balancing this in basic medium, the next we have to consider is wherever there is oxygen deficiency, you are not adding water only, but you're adding both water and hydroxide ion. So we're adding both water and hydroxide ion here. And when we have sufficient oxygen, we are adding water molecule there, H2O. After this, let's do the next thing. The next thing is to balance the atoms. So how to balance the atoms? This is chlorine. Chlorine is 1 here. Chlorine is also 1 here. Chlorine is balanced. Oxygen is 3 here. Oxygen is 1 here. Oxygen is 4. But here, oxygen is 1 plus 1. That is 2. So what do? Let's place 2 here and also place 2 here. So oxygen is definitely balanced. Let's check the other side for hydrogen. Hydrogen is 2 here. Hydrogen is 2 plus 2. 2 times 2, that's 4. And here is 2 times 1, that's 2. 4 plus 2, that's 8. 4 plus 2, that's 6. So what do here? We need to place like 3 here to make hydrogen 6. Let me teach you the best way of doing this in basic medium. You don't have to stress yourself that much. Whatever you have here, that's exactly what you'll be having here. So in balancing this in basic medium, instead of me stressing myself over that for a very long time, since I have deficiency of oxygen somewhere, all I have to do is whatever I have here should be the same as what I have at the hydroxide part. Since oxygen is 3 plus 1 here to make it 4, oxygen is 1 plus 1 to make it 2 here. So what do? If I place 2 and oxygen and hydroxide to be 2 here, definitely I will also place 2 here. If I place 2 here to affect this hydroxide, I will definitely place 2 here to affect this water. Oxygen is 3 here, oxygen is 2 here, oxygen is 5 in total. Oxygen is 2 here plus 2. Oxygen is 4 here. Oxygen is unbalanced. So what do? We need to increase it again. When I place 3 here, I also place 3 here until oxygen becomes balanced on both sides. This is 3 plus 3, that's 6. Oxygen is 5 here because this is 3 plus 2 to make it 5. I will increase this again. If I make this 4, I also make this 4. Oxygen is 6. This 4 here plus 3, that's 7. Oxygen is 3 plus 2, that's 6. I will increase this again so that I make this 5. I also make this 5. If this is 5 plus 2, that's 7. This is 5 plus 3, that's 8. Make this 6. Make this 6. This is 6 plus 3, that's 9. This is 6 plus 2, that's 8. What do I do? Let me increase this to make it 9. So oxygen is 9 here. Oxygen is also 9 here. Then I'll balance that of hydrogen. Hydrogen is 6 times 2, that's 12. Hydrogen is 3 times 2, 6, plus this 6 to make it 12. So, since the equation is balanced, since the atoms are balanced, I need to balance the charges. How do I balance the charges? This case, this is negative 1 for chlorate. Here is minus 6. That of water is 0. To give this negative 1, water here is also 0, and hydroxide here is negative 6. This is negative 7 to negative 7. That means the charges are balanced. That's sulfur 4 oxide to sulfite. This is definitely undergoing oxidation because there's an increase in oxidation number, and number of electrons will be placed here. How many electrons? 2 electrons. There is deficiency of oxygen here, so we are adding water. We are also adding hydroxide to this. Here there is enough oxygen, we are only adding water to this. So how do you balance it? The best way, I told you then, balance, look at the hydroxide here and be considering the water here. The number of molecules of water will be the same as the number of molecules of hydroxide here. So I'm placing, let's check if the atoms are balanced. This sulfur here, sulfur is 1 here, sulfur is 1 here, sulfur is balanced. Oxygen is 2 plus 1, 3 plus 1, 4, oxygen is balanced. Oxygen here is 3 plus 1, 4, oxygen is balanced. Let's balance hydrogen. Hydrogen is 2 plus 1, hydrogen is 3 here, hydrogen is just 2 here. What do? Let's place 2 here. Hydrogen here is 4, hydrogen here is 2, then we'll place 2 here to make hydrogen to be 4. So oxygen is 2 plus 1 plus 2, that's 5. Oxygen is 3 plus 2, oxygen is 5. Hydrogen is 2 plus 2, 4. hydrogen is 2 times 2, 4. So the charge atoms are balanced. When you balance the charges now, how do you balance the charges? This is the charge on this is nothing. There's no charge on this. There's no charge on this. The charge on this is -2 because this 2 times -1 will give you -2. Then going to this, the charge on this is 2 times -1 will still give you -2. So the charges are balanced in this case. This is equation 1 and this is equation 2. We need to look at the coefficient of electrons in both sides. Coefficient of electron here is 6, coefficient of electron here is 2. So what do? We need to multiply this by 2. We'll multiply this equation by 2. I'll multiply this equation by 6. Then the equations will be 2ClO3 minus plus 12 electrons plus 12 water molecule to give 2Cl negative plus 6 H2O plus 12 hydroxide ion. For the other one, since I'm multiplying all this by 2 by 6, since I'm multiplying all this by 6, this becomes 6 SO2. This is gas. Plus 6 water molecule plus 12 hydroxide to give 6 SO3 plus 12 electrons plus 12 water molecules. So now that the electrons are virtually multiplied by the coefficient of electrons, the next thing to do is to add the two equations. So what I will do here is I have this being added to this, or from here I can even decide to cancel the electrons. This cancels this. Anything that needs to cancel should cancel. 12 H2O cancels 12 H2O. 6 water molecule cancels 6 water molecule still. I have 12 OH cancelling with 12 OH. So I'll be left with this. That's 2ClO3 minus plus 6 SO2 to give 2Cl negative plus 6 SO3, that's gas. So this is the net equation, but we can still work further because all of them can be divisible by 2. So the next we'll divide through by 2. So when you divide through by 2, this then becomes ClO3 minus plus 3SO2 gas to give Cl negative plus 3SO3. So this is the net equation.